All right, so I think those were the only steps you need to compute histogram of oriented gradients. And now let's try to understand. So only missing link is how to compute the histogram. We'll talk about that. Now let's take a step back. So if this is your full image, and as I said, it was firstly used for person detection, but of course you can use for anything else as well. So in case of person detection, you had like image something like this, where you have a person. And that was the reason, like the full image you have, it's like a rectangular shape, right? It's not square shape, because humans, we are like, we don't have square shape, right? So that's the only reason. So given the input image, what you do is you know like what will be the cell size, the final cell size you will have inside your blocks. Okay, so you just create these grids, and these are your blocks. So that is like first block, again blue is the second block, and you can see that you know again how many pixels you will have in each block. All right, so each block has 2x2 cells, which is fine, 4 different cells, and size is 8x8. Okay, so each cell is actually 8 pixels high and 8 pixels wide, which means that your block will be 16 pixels by 16 pixels. Okay, and again, those are just numbers. If you have very high resolution images, this might change as well. But in this particular case, let's say these are the stats. And this will be useful because at the end, you will be interested in like, what will be size of your feature and like how you have to normalize. So for that, you need like these statistics. Okay, so what you do is you place these blocks at all these possible locations after creating this grid. And for each block, you extract your feature. Okay, and then again, you slide the block. And again, you extract the feature, and you do that like all over again. And at the end, like for each block, you will have some set of features. So what you do is you just concatenate all those features together, and that will be a very huge feature vector, and that will represent your image. Okay, so that's how it works if you have to extract features using HOG from a big image. But essentially, the core of the algorithm is how to extract features for this one block. If you know that, you can extract features for the whole image as well. You just slide it. Okay.